talk about the underlying technologies that are fundamental for what's causing this digital revolution. And so as I go through this, I'm going to be talking about some concepts and some processes that are still very much in the experimental stage, and a lot of it has some very recent development.
Dean Mischke of Finley Engineering gave today's keynote speech at the Wisconsin State Telecom Association 2009, the Fall Conference. So we're here with Dean. Theme of your talk was Imagine If. So why don't you tell us, you went from the micro to the macro level, why don't you tell us a little bit about some of the things you talked about?
Well, the whole point of the presentation was to get people thinking about not what's happening today, but what will happen, say, in the next 5 to 10 years. And so a lot of the things that I talked about may not necessarily make it to fruition, but imagine if it did, what would their impact be on how they interact with technology? And then to take it one step further, how would it impact their business? And are they taking the steps to be prepared for that? And so that was really the whole concept of looking at at the issue of Imagine If.
Well, and what I liked about your presentation was you looked very granular to the nanometer level, but also at the high level. Why don't you tell us a little bit about some of the nanometer stuff?
Well, some of the things that we're seeing today in technology, we've outgrown some of or we've hit a point in our technology where we can't make things any smaller than they already are. Imagine if I took this device and I made it 32 times smaller. Or, conversely, 32 times faster, 32 times more powerful. And so people had thought that we'd reached a plateau of how small and powerful devices were going to be. And with some recent developments, and it's amazing that all of this is coming out of the chemical and physical world and not the engineering world, they're now arriving at processes whereby you can take and start making things incredibly small. And we thought we'd achieved that point already, but now we're talking about quantum steps where we're going 32 times smaller than what we are today. And so it's the ability to take a device that we have today in our hands and either make it 32 times smaller or 32 times more powerful. And so it's that trade-off and choices in what you want to do. What I really enjoyed about the presentation was the fact that I looked at the nanometer level of how we make a chip and brought that all the way up to the macro level of how some of those products and chips will reach us in the future.
And the thing is, the future really isn't that far away.
Some parts of it are not. A couple of things I talked about, for example, the NVIDIA GPU-type server, a processor that can do 1 trillion operations per second, is actually available today, and it's been available for about 6 months. It's really not common knowledge yet, but some of the other things, for example, the contact lenses with the imprinted circuit boards, someone come up after the presentation and said, well, I don't know if I want that because the eyes are the soul to the portal to the soul, and it would be so mechanical. But I said, take a look at the other side of things. If you could detect a reaction in your body far faster than any of the methods they use today and prevent it from causing you harm, would you accept it? And they had to admit that, yeah, maybe they would.
Yeah, and we are actually starting to see those kind of developments happen with people who are blind, and now they are starting to see.
Yes. That was one of the original goals of the contact lenses. They thought they were going to use that to restore sight, and I think they realized that may not be a practical application, but it will be extremely powerful for somebody who has macular degeneration to be able to give them the full field of view by focusing the light that's there down through that small portal.
So, with all this data flowing around, with data literally in the eyes, what does that mean for the telco?
Well, it's still going to mean the need for bandwidth. And a lot of the things I talked about today may have pointed towards the wireless world, but at some point we're going to need to collect that information and take it back to a usable source. And so that's where the telcos may be wanting to look, as to be that collection point within the house. And instead of allowing it to go wirelessly beyond that point, if we take a look at the amount of bandwidth that the telco can make available, they far outshine anybody else right now in the industry. And so that might be one of the things to focus on, is just how to be the collection point. And once you're the collection point and then also the customer interface, now you become valuable as compared to just being a pipe.
That makes sense. So add value by being the collection point and being there for the customer.
That's right, and being able to provide the technical services necessary to make things work seamlessly, because that's really what customers are headed for now. As a lot of people don't understand how and why the system works, all they want to do is work.
Yeah, and literally, if that contact lens quits working, I won't be able to see. So, right. Dean, thank you very much.
Well, thank you very much. The last device I want to talk about is actually being worked on. And yes, it is what you think it is. It's a contact lens, and it has circuitry embedded in it. Imagine if